Now, float versus boost charging. Float charge 2.23 to 2.27 volt per cell. This is float charge. Okay. So, continuous trickle charge to maintain battery at 100% capacity. Continuous. Why we are keeping it floated more? Because it should be 100% charge all the time, maximum capacity. That is why it is floated. So compensate for self discharge, uses 99% of the time during normal UPS operation, keeps batteries ready for discharge without overcharging. Okay, without overcharging. Voltage critical, too high causes water loss and grid corrosion, too low allows sulfation. So this is the float charge. Now boost charge, very fast. Boost charging is happening for our electrical vehicles. Okay, 2.35 to 2.40 volt per cell. Periodic high voltage charge to equalize, periodic, not every time, to equalize cells and remove sulfation, typically quarterly for 4 to 8 hours, quarterly. Breaks down surface crystals that accumulate during float, causes gassing and water loss. It will cause gassing and water loss. Monitor closely while doing this boost charge. Not recommended for VRLA. If temperature compensation is working properly, then boost charge is not recommended. If your temperature is properly compensated, you can use float charge, and generally we use that only. We don't use this. Okay, this is for EVs. Okay, now why temperature compensation is critical? Okay, voltage adjustment is equal to minus 3 millivolt per degree Celsius, minus 3 millivolt, okay, per cell from 25 degrees Celsius baseline. If from here, if it increases, the voltage adjustment minus 3 millivolt per cell, okay, per degree Celsius, every degree Celsius. Example, 48 volt battery, 24 cells at 35 degree Celsius ambient needs 0.72 volt reduction from 25 degree set point. Okay, reduction will be there, 72. Okay, so without temperature compensation, overcharging at high temperature accelerates water loss and aging. So over temperature, no, it will accelerate the aging. Don't do that. Okay, don't increase the voltage. Under charging at low temperature causes sulfation. Both ways there is a problem. So it should be precise. So most UPS have temperature probe to verify its actual connected and calibrated. Okay, so many FMs discover disconnected temperature probe after premature battery failure. So just check if probe is there. It should not be disconnected because UPS is using its feedback temperature. Okay, now overcharging versus undercharging. Overcharging, high water loss because of overcharging, bulging cases, it can bulge. Okay, VRLA, in case of VRLA, high temperature reduce life. Obviously temperature is the killer of life, caused by incorrect float voltage, failed temperature compensation, undercharging, sulfation buildup because of undercharging, then reduced capacity, then voltage drop under load. Under load voltage will drop, caused by low float voltage. These are the causes by low float voltage. Insufficient charge time, both kill batteries, undercharging and slower and harder to detect. So overcharging and undercharging both are killers of battery. Just note this down. This is very much important. We should understand. It should be optimized charging. Okay, precise charging. So just check with your vendor, UPS vendor or battery vendor, what is the exact charging current and whether it is applying to it or not. Okay.